Audio Jungle. Audio Jungle.
Hello everyone, myself Singh Maurya and hope you all are doing well. So guys, today we'll solve GATE 2015 performance problem, right? So here this is problem number 16. It is asked for 1 marks in 15. So now this question is check. Read it. Consider the density and altitude at the base of an isothermal layer in the standard atmosphere to be ρ1 and h1. Okay, respectively, the density variation with altitudes rho versus h in that layer is governed by r specific gas constant T, temperature G naught, acceleration due to gravity at sea level. So, all right. So basically, if you read this, then one thing they had given, it is isothermal layer. See, in our atmosphere, okay, solution of the problem. If you go for the atmosphere chapter in performance, so total number of layers are 5, okay, but here basically we are talking numerical point of view, that is troposphere and stratosphere. Okay, stratosphere, we have total number of layer 5, ionosphere, exosphere, yes or no? So mesosphere. So these are the layers, but basically for numerical point of view and whatever the formula available for us, it is troposphere and stratosphere. So troposphere is basically 0 to 11 kilometer vertical upward direction we have to count, and 11 kilometer to, it is approximate 25 kilometer. Okay, that two cases we have, and always like previous few problems we had solved based on troposphere as well as the stratosphere. In previous year question paper also it was asked. All right, and if it is not asked also, troposphere, like if suppose they have mentioned like aircraft is what flying 3 kilometer, 5 kilometer altitude, 10 kilometer altitude, 7 kilometer altitude. So at that particular altitude, if you want pressure, temperature, density calculation, then obviously it comes under a troposphere. So anyhow we have to use the formula for the pressure, temperature and like density. Okay, anyway, so like troposphere formula I had used, similarly we'll have a stratosphere. Okay, so why I have written this, because I just wanted to tell you in troposphere that temperature, pressure, density variation, I mean whatever the variation, that is temperature, pressure and density, these are varying, okay, in troposphere, but in a stratosphere only pressure and density variation we have. Hmm? But what about temperature? So temperature is what? Temperature is constant in stratosphere. In stratosphere, you need to remember this. Okay, this is the remark point. Okay, this is the remark point. In stratosphere, I'm saying in stratosphere temperature is constant. So temperature is constant. That's the reason it is given isothermal. So they can say stratosphere directly, or they can give altitude between 11 to 25 kilometer, or they can say isothermal layer, because temperature constant means what? Isothermal. You know very well. Constant temperature means isothermal. Isothermal. All right. So like troposphere, already I had given number one, temperature. How that temperature is what? Troposphere means 0 to 11 kilometer. Okay. How that temperature will vary at any altitude? If you want to calculate temperature, then you have to write sea level temperature T naught lambda h. What is the lambda? It is lapse rate. What is the value? 0.0065 Kelvin per meter. All right, or 6.5 Kelvin per kilometer, means 1 kilometer in upward direction if you go, then 6.5 Kelvin temperature will fall. That's the mean of it, lapse rate. So temperature you can calculate. Similarly, if you want to calculate pressure at that particular altitude, so pH, H is the altitude at any altitude. So pH and sea level pressure you know, then it is nothing but TH divided by T naught to whole power G by lambda R, or you can write TH by T naught G by lambda R. If you calculate, it is 5.25. What is the lambda? 6.5. G sea level meter per second gravitational acceleration. R is, because in atmosphere we have air, so 287 joule per kg Kelvin, R value. All right, that you know. Similarly, third number is density. If you want to calculate rho h by rho naught, that is TH by T naught. Okay, G by lambda R minus 1, which is nothing but TH by T naught. Okay, 5.25 becomes 4.25. So this is the variation of pressure, temperature, and density in troposphere. Okay. Similarly, we'll have a formula for the stratosphere. Similarly, we have a formula for the stratosphere, and that formula you need to remember. Okay. And as I mentioned, that variation of the pressure and density will have. What about temperature? Temperature must be constant. All right. So that you need to remember there. So for the stratosphere, I will write the value for the, because this question is for stratosphere. This question is for stratosphere because it is mentioned isothermal layer. So just for your just like a reminding purpose, I have reminded this, like for troposphere this is the formula, but this question is for stratosphere, so I will erase this. I will write the formula, similar formula for the stratosphere, because troposphere formula many times I have given. So it is from 11 kilometer to 25 kilometer, because this question is for stratosphere. Stratosphere also called as a isothermal layer. I told you why, because isothermal means temperature is constant. That's the reason stratosphere, strato, it is related to the temperature. Temperature is what not varying. Okay, stratosphere. So temperature is what constant. It is called isothermal layer, which is given in your problem. See, it is given isothermal layer. All right. So number one, temperature variation. So at, see, like temperature is what constant. From where it is constant? From 11 kilometer to 25 kilometer. Okay. Number one. Number two, if you want to go for the density or first pressure, so our pressure is what? P. Okay. You can say that pressure, if you want to calculate, okay, as per this notation, okay, they are asking density, no problem. So P divided by P1, okay, is equal to E to power minus G by R T11. Now 11 kilometer temperature you have to write, 11 kilometer. Okay, in bracket h minus h1. All right, hope you understood this. This is the formula. Okay, because if you check here, they have given density versus altitude, so h is the altitude. All right, and the standard atmosphere to be rho 1 and h1. So rho 1 and h1 is the altitude which is given. Density, the under, consider the density and altitude at the base of an isothermal. Base of isothermal means at 11 kilometer. At 11 kilometer, what is the uh, altitude you are considering here? h1. So h1 is the altitude at 11 kilometer, because now after, see, 0 to 11 kilometer, just think, 0 to 11 kilometer it is troposphere, and from 11 kilometer to 25 kilometer it is stratosphere. So now your reference is nothing but 11 kilometer. So at 11 kilometer, what altitude you have to write? h1. And here if you want to calculate, then this is nothing but h as per this question. So for that case, what will be the P upon P1? P1 is the basically altitude at 11, pressure. P1 is the pressure at 11 kilometers. So first you will calculate pressure at 11 kilometers. Then at any altitude, if you want to calculate, you can calculate. Okay. I will write this PH by P1. So this H is the altitude. I will mention this is H1 and this is what? H. This h1 is what? 11 kilometer. Now hope you understood. Now if you want to calculate pressure at this altitude, at any altitude, I mean in a stratosphere, maybe 20 kilometer, 25 kilometer, 13, 15, 17, any distance, any altitude, then that value you have to keep. So this is the pressure. Third is what? Density. So density at any altitude, if you want to calculate, then you should know density at 1 means it is 11 at 11 kilometer density. You should know what will be the formula. E to power minus g by rts h minus h1. Check, both formula are same. Pressure and density formula are same. Okay, so nothing to worry. Whatever the why it is, because you know state equation of state, no? What is that? P is equal to rho rt. Temperature is constant, r is constant, so P directly proportional to rho. What will the formula? Same formula will have density. So it is rho h by rho 1, or the same thing, rho h. In our this numerical they have not mentioned h, so it is rho is the density at any altitude, rho 1 is the density at 11 kilometer. So yes, our formula is what? It is like rho by rho 1 to e to power minus g by rts, or 11 kilometer, or only s is the stratosphere. Okay, or here in this option they have not given, so you remove it, no problem. Okay, now, and it is nothing but h. So check, this is your answer. Which option is correct? See, option 1, first one is correct. Rho by rho 1 e to power g not by rt h minus h. That's all. Okay, remember it. Remember, h is the altitudes. Okay, at any altitude, h1 is the altitude at the base of isothermal. Base of isothermal means this is the base of isothermal, 11 kilometer. Above 11 kilometer we have a stratosphere, below this it is troposphere. I hope you understood. Simple one. So this answer is correct. Okay, your correct answer is option A. Okay, answer is option A. Okay, all right, now we'll go for next problem. So this is problem number 27, again same grade 2015, 2 marks. It is given aircraft in level and unaccelerated flight. With unaccelerated flight means steady flight. Okay, with a velocity v infinity 300 meter per second, requires a power of 9 into 10 power 6 watt. If the aircraft weight is 1.5 10 to power 5 Newton, the lift to drag ratio it is asking. So you just write the given data first. See, v infinity it is given 300 meter per second. Huh? requires power. Power required, I will denote by PR. It is nothing but 9 into 10 power 6 watt. Weight of the aircraft is, it is given 1.5 into 10 to power 5 Newton. All right. Okay. And it is mentioned level and steady. So I can write steady and level flight, steady and level flight. So this is the condition. Okay. This is the condition it is given. All right. What we need to calculate, it is mentioned L by D ratio. All right. So simple one only. L by D ratio here it is asking. So we know very well. We know that at steady and level flight condition, very well known condition we know. What is the steady and level flight? Suppose this is the aircraft, okay, and obviously this will steady and level flight. This will be thrust, drag will be opposite to this, okay. So at steady and level flight condition, it is thrust is equal to drag and lift is equal to weight. This is the very well known condition. All right. You know power required, PR. What is the power required? Why power required? To like whatever, because of the drag there is the losses, continuous losses will, because drag is what opposite force. Okay. To balance the drag force, we need a engine power. To balance the drag force, we need engine power because drag is equal to thrust. So thrust it is produced by the jet engine, yes or no? So basically, why power required? So you can say it is because of the drag. If drag is will be there, then power required will be there. If there is no drag, so obviously power will not required. Hope you understood. So power required is nothing but drag into velocity, force into velocity. What is the force you have to write for the power? It is drag. All right. So drag into velocity. Velocity is given. You can calculate drag. What is that? Power by velocity. Let me calculate this. So if you write drag, say power, what is the value? It is 90 Newton power 6 divided by velocity. All right, it is nothing but 30 into 10 power 3 Newton. Okay. And you know what is the lift? Lift is nothing but weight in steady flight. What is the weight is given? It is 1.5 into 10 power 5 Newton. Huh? 1.5 into 10 power 5 Newton. What is the lift by drag? Lift by drag is nothing but what? 1.5 into 10 power 5 divided by 13 to the power 3. How much it is? It is nothing but 1.5 10 to the power 5 divided by 13 to 10 power 3. It is 5. They may ask also like L by D or CL by CD. Both must be same. It is nothing but 5. So what is the correct answer? It is fill in the blank, I think. Check. Yes. So that answer will be 5. There is no unit answer. Hope you all understand this. Yes or no? It's a simple only. Just use the logic, basic idea only. So this is the answer. Answer is 5. All right. We'll go for next problem now. Okay. Again, this is GATE 2015 question number 42. It was asked for 2 marks. All right. So we'll read this question. What it is given? An aircraft with wing loading. So first I will write the given data. So it will be better. In exam, you guys don't write given data and all. Or you just start calculation. Okay, just directly write value and start calculation. Don't waste your time. Here I'm So I'm giving the solution. So once I'm writing everything like what need to calculate, what condition they have given, what they want, like what value they are asking, what we need to calculate, everything I'm writing. What in examination no need to write. You just see the value, write it on that notepad will be given to you where you have to calculate. You just start calculation, use the formula and write, calculate it. No? So wing loading, what is the wing loading? I told you, wing loading is denoted by small w and it is nothing but weight of the aircraft divided by wing planeform area, which is nothing but 500 Newton per meter square. This is given to you. Gliding at L by D max, okay? So L by D max is given. Remember this L by D max also called as minimum drag condition. Minimum drag condition. Here not required or maybe required, but I'm giving you L by D max anywhere if you get it, automatically you need to understand this is the minimum drag condition and how much it is given 10. It is also called aerodynamic efficiency. Just for knowledge I'm giving, okay, everything you need to remember. Aerodynamic, this is also called aerodynamic efficiency. All right. And what value they have given? CL they have given how much? 0.69. You need to understand L by D max is given minimum drag. So at minimum drag condition or L by D max, whatever the value will be given to you, CL, that CL value will be nothing but it will be CLMD, means CL value at minimum drag condition. It is given how much? 0.69. Hope you understood. Considering the free stream density, it is sea level value, not sea level, just stream density they have given, not sea level, 0.9 kg per meter cube. The equilibrium glide speed in meter per second. Okay, equilibrium glide speed in meter per second. So here, anyway, this is the glider problem. So I will solve from very basic. So I will draw the diagram. Otherwise, even not required directly, you can calculate. But yes, I will follow all the steps so that it will be very easy to you to understand the problem. This is the glider. Gliding angle is gamma. Obviously, weight will be acting downward and lift force will be acting perpendicular to the velocity. Here, this is the velocity and lift is here. Huh? So, obviously, this will be gamma. So, this component will be W cos gamma, and here this component will be W sin gamma. This is opposite to drag. Thrust for the glider, you know that, no? For glider, thrust will be 0 because it is also called, glider is also called unpowered flight. Maybe engine is switched off or turned off, or it is without power. No? So what value you may get? L is equal to W cos gamma you may get, and D is equal to W sin gamma. So what will be the tan gamma? It is D by L. Yes or no? Or tan gamma is equal to 1 by L by D max, you can write. L by D max is given, hence this value will be minimum. Okay. It is called minimum gliding angle. And minimum gliding angle you may get at minimum drag condition. Okay. That is the condition L by D max condition. So at this condition, what you need to do? Check the equilibrium glide speed they are asking. You need to calculate the equilibrium glide speed. Okay. So at what speed you have to calculate? I mean, at what condition you have to calculate that equilibrium speed? That is L by D max. I told you what is the L by D max condition. L by D max condition itself minimum drag condition, and that's the reason at that condition they have given CL. So this CL is nothing but CLMD condition, minimum drag condition. All right. So they have mentioned at equilibrium. Okay. So at equilibrium, they are saying at equilibrium. Okay, even though they have not given gliding angle. So at equilibrium, you can say why that gliding angle is like because L by D max means gliding angle is minimum condition. See, I have told you here this gamma is minimum condition, minimum value. So you can say that gamma is what negligible. You can say because it is L by D max condition. So gliding angle must be minimum. L by D max means gliding angle will be minimum condition. So minimum condition so that you can consider gamma is very a small value. So now gamma is very small. You understood why I'm saying gamma is very small? Because if L by D is max, then this value will be minimum. So gamma is very small. So what will be the cos gamma? It will be it will be 1 only. If gamma is approximate to 0, so cos 0 is what? 1. So cos gamma you got 1. So here L W cos gamma you have approximate, you can write W, L is equal to W. So what is L? Half rho V square S into CL, okay, is equal to W. Yes or no? Now, so here you can write this V square is equal to what? 2W divided by rho S CL. Yes or no? Now, what is the velocity? So at L by D max, this condition is also called, I told you, you need to remember it is called minimum drag condition. Okay, minimum drag condition. Minimum drag condition, hence whatever the velocity you may have, Vmd, what is the lift coefficient you may have, it is Md. So what is the mean of Vmd? Okay, it is speed at minimum drag. Md means minimum drag. Speed at minimum drag. What is the CLMD? Hmm? Lift coefficient at minimum drag. Because it is clearly mentioned glider is what gliding at L by D max condition. So whatever the value you may get that time, all value will be related to minimum drag condition or L by D max condition. All right. Now you calculate VMD. 2, you can write W by S, okay, rho CLMD. Check 2W by S is the wing loading. How much it is given? 500. So I'll write all value 500. What is the rho? I think 0.9, no? 0.9 and CL is 0.69. It is 0.9 and 0.69. If you calculate here, let me check this value. 2 into 500 divided by 0.9, 0.69. Okay. It is 40.12 meter per second. Check, this is fill in the blank. Okay, it is meter per second already mentioned. So you write only 40.12. That's all. So this will be your answer. Hope you understood this. This is your answer. All right. This is your answer. Hope you understood. For any steps, suppose you are not able to understand or you have any doubt or if you want to ask any questions, you write comment on comment box. So definitely I will answer for that. Okay, no doubt. We'll go for next problem, dear. The same gate 2015. This is question number 47, and it was also asked for the 2 marks. All right. So check. This is the problem. The pitot tube of an aircraft. The pitot tube of an aircraft registers a pressure P naught. P naught means total pressure. basic notation, not means total. So it is total pressure. The static pressure density and the ratio of a specific heat of the free stream. So this is the static pressure, this is the density, and a specific heat, ratio of a specific heat means gamma, Cp by Cv. This ratio of a specific heat is nothing but gamma, it is given 1.4. All right. So given data, okay, P naught is 54051 Newton per meter square. Static pressure, it is denoted by P infinity 45565 Newton per meter square. Density 0.6417 kg per meter cube. Static pressure, static density, and gamma is given respectively. The indicated airspeed in meter per second. This is the question. This is the question. Okay. So for the Python tube, you know very well where we need to install. It's a simple one only. Hmm? Okay. This is the suppose aircraft. So where you have to install, maybe here, that should be undisturbed, very simple. Anywhere, maybe at this place or maybe at this place also sometimes. So depends. Anywhere. So this Python tube is what measuring total pressure and static pressure. So for this we need to calculate indicated airspeed, and that will be in meter per second. So option here it is given. Okay. All right. So generally that concept of the indicated airspeed I had explained many times. It is basically whatever the indicated speed, it is indicating on dial, and directly you have to read after correcting the, like, direct, whatever the indication you are getting on pointer, that will be the indicated airspeed. And then you may have a calibrated airspeed, then you may have equivalent airspeed, then you may have a true airspeed. All right. So that I already have given this in previous year problems. If you check my previous videos, so you may get that two times, two, three times I had given that. So here directly I will write indicated airspeed, and this is the formula. So okay, I will give indicated airspeed. Okay, this is the derivation, but I will suggest you directly write this formula and remember indicated airspeed in terms of P naught, P infinity, rho, and gamma. Okay. There are another formula also for indicated airspeed, but if they are asking indicated airspeed in terms of P naught, P infinity, rho, gamma, these are the value suppose given. So that time you have to use this formula. Write this indicated airspeed or is equal to, this is the derivation. Okay, dear. This is the derivation 2 gamma upon gamma minus 1 P infinity divided by rho P naught by Ps to whole power gamma minus 1 by gamma minus 1. All right. And this is nothing but in root. This is the derived formula. Okay. So no need to derive here. You just simply remember this. This is the P naught, means total pressure. P infinity. Sorry, it is the P infinity. Actually, my marker is, this is the P infinity. Earlier it was P infinity only. Correct it, no? Now fine. Inside it is P naught. Now keep the value. So it is nothing but 2, 1.4 divided by 1.4 minus 1. What is the P infinity? You check it. 45565. 45565. And what is the row? What is the row? 0.6417. 0.6417. P naught, it is 54051. 54051 divided by static 45565. Okay, keep all value. Okay, if you calculate this, okay, keep all the value in calculator. Check. This is nothing but 54051 divided by 45565. Okay, to whole power gamma minus 1 by gamma 0.4 in bracket 0.4 divided by 1.4. You also can calculate minus 1, then multiplied by 45565 divided by 0.66417. All right, multiplied by 2 into 1.4 divided by 0.4. Take root. Okay, this is nothing but in root how much? 24855.714. This value approximate. You just check how much it is. 157.65 meter per second. Check any option is there. 157.65. This first option exactly the same. 157.6. Huh? So you need to calculate there. What is correct answer? Option A. So very simple. You just remember the formula. Some another day I will tell you the derivation also when I will conduct this subject. Then I will give the derivation also. Here I have given directly this. Hmm? So I'm going very slow because I'm giving the solution here. Okay, I'm not writing exam, but for you guys, you have to go very fast. For that reason, you need to practice more and more numerical. Okay, your calculation should be very fast, no? So that you can finish one numerical at least 2 to 3 minutes, max to max 4 minutes, not more than that. If any numerical taking more than 4 minutes, so definitely there is some problems because whatever the question will be asked, it will be asked like in such a way so that you can finish 65 question in 180 minutes. All right. So at least one question you should give like 2 to 3 minutes. Anyway, this problem is done. We'll go for next problem. Okay, this is the problem again GATE 2015 question number 60. What is the question number 60 here? Check. For a level flight, at cruise altitude, CD value it is given how much? 0.018 with drag coefficient at 0 lift, CD naught. Okay, 0.015 for a 30-degree climb at the same altitude and speed CD. So this is the climbing case. Okay, so climbing flight. Okay, all right, I will give this information here, but Not all the derivation point is required here, but yes, whatever the required things I will do. So what is the given data? Check. Uh, for a level flight at cruise condition, it is given CD value. CD value is what? 0.01 at with drag coefficient CD naught 0.015. All right. So this is for what? Level flight. Okay. Now next, it is climbing flight. So for the climbing, it is given climb. So climbing angle is given how much? 30 degree, and at the same altitude you and speed, same altitude and speed it is given. You need to calculate CD. Okay. So this information is what for climbing flight. Okay. That should be very clear. Hmm? This is the one condition. But here we have a this is the climbing flight. What is the climbing angle? Gamma. Yes or no? What is the climbing angle? Gamma. Wait. Wait. Let me correct this. Okay, now fine. No problem. This is what? Gamma, climbing angle. Okay. Aircraft is not moving in this direction. It is climbing. So perpendicular to this will have a lift force. This is the lift, and opposite to this motion will have a drag. This is the W. This will be gamma. So this will be W cos gamma, and in this direction will have a W sin gamma, and definitely thrust will be used to give forward motion that aircraft. So now we'll got thrust is equal to drag plus W sin gamma, equation number 1. Equation number 2, L is equal to W cos gamma. This is for the climbing flight. Hope you understood this. Hmm? What is the gamma? It is climbing angle. One thing it is very clear, same altitude and speed. Okay, condition it is given, same altitude and speed. It is given to you. Okay. Now, so you check if drag coefficient they have given what? CD they have given, and CD naught they have given. It is given. What is CD naught? It is parasite. Parasite drag. Parasite drag is the constant drag, no? Constant drag or zero lift drag. So doesn't matter at what altitude it is flying, it is climbing or it is gliding or it is whatever the maneuvering condition, doesn't matter. Zero lift drag, it doesn't depends on the orientation of the aircraft. It is a constant drag. So that must be constant for the climbing and for the level flight. Yes or no? CD naught must be constant because it does not depend on the orientation of the aircraft, or it does not depend on the operation of the aircraft. I mean, it is climbing, turning, gliding, whatever the condition, doesn't matter. CD naught must be constant because it is a parasite drag. Hope you understood. So what is the relation between this CD and CD naught? You can write, it is called drag polar. It is called drag polar. CD is equal to CD naught plus CDI. CD naught plus CDI is also you can write KCl square. Okay, CD naught is the zero lip drag and CDI is the induced drag coefficient. What it is called? Induced drag coefficient, and it is also called lip dependent drag. Lip dependent drag coefficient. All right. So this CDI will change. It is climbing or it is gliding or it is turning or it is level flight. CDI will change. Why? Because it is lift dependent drag. So all condition lift will be changing, right? Like turning, for the turning, definitely lift will not be constant. I mean, it will depends on that situation. Climbing lift will depend on that situation. Okay, gliding lift will depend on that situation. So if lift is what changing, so CDI will be changing. What is the CDI formula you got here? KCl square. This is the formula. So as I mentioned, CD naught will be constant for both conditions, but CDI will be depending on the orientation. CDI will be depending on the operation of the aircraft. CDI. So what you will do, like they are asking here the value CD value for the climbing case. They are asking CD value for the climbing case. So we'll do one thing. We'll take this CDI and for both condition we have to write the CDI, because for both conditions CDI will be changing. So CDI we can write. What is the CDI formula? KCl square. What is the K? K is the constant. What is that? 1 upon pi E AR. This is also constant. Why? Because pi constant is the Ostwald efficiency factor. You know that. Ostwald efficiency, this is also constant. It is a geometrical parameter for the wings efficiency, Ostwald efficiency. And what is the aspect? AR is the aspect ratio, no? AR is the aspect ratio, that is also a wing geometrical parameter. So this is also constant. So overall K is constant. So what is the variable? Only CL is the variable. So now we can write this. What we can write? Simple. We can write CDI. Okay, CDI for steady level. So what value you may get? You may get K for the sea level. Check for the sea level. What is the lift? Lift is equal to weight. Drag is equal to weight. Thrust is equal to drag. But for the climbing case, what is the lift? L is equal to W cos gamma. You need to remember this. Okay. Now so we can write K. What is the CL value? KCl square. What is the CL? You know this basic formula, 2W rho S V square. You know this basic formula, right? So KCl square, hence 2W rho S V square whole square, because it is KCl square. No? Check, CDI is nothing but KCl square. So I am writing this. K is constant, so no need to write. Similarly, you can write CDI for climbing. Yes or no? For climbing flight, it is nothing but K 2. And yes, what is the L value? Because W is L, hence I am writing directly 2W. Actually, this is 2L by rho S V square, right? CL is what? What is the CL? Basic formula for the CL is 2L divided by rho S V square. But L is equal to W, hence I have written W. But for the climbing flight, what is the L? L is nothing but W cos gamma. So L is equal to W cos gamma. So I will write cos gamma divided by rho S V square. I hope you understood this. Now we can write this. Take the ratio. So most of value will be cancelled out. So you will get, because I need CDI for the climbing flight. So I will write this in numerator, climbing flight. No. So what value I will get? Check. This is nothing but you write directly. So all the value will be cancelled out if you write the ratio. So CDI climbing flight will be CDI for the steady level flight. Directly I am write the value so you can understand. Most of value like rho will be constant because they said altitude is constant, so rho will be constant. They said same speed, so v is also constant. So all value will be cancelled out. What you may get? Check climbing flight, no? So cos gamma is square. Yes or no? Rest everything will be cancelled out. Check it. You may get that. Yes or no? From here, if you check in the problem, CD is given, CD naught is given, you know directly CD is equal to CD naught plus CDI. Check what will be the CDI then for the level flight. CDI will be CD minus CD naught. How much it is? CD minus CD naught. CD is given 0.018 minus CD naught is 0.015. It is 0.003. Write it here. Okay, you write it. It is nothing but 0.03. Yes or no? Into cos. What is the climbing angle? Check. Is given 30 degree. Yes, it is given cos 30 degree square 0.03. What is the cos 30? Let me calculate. Cos 30 is 0.86 square 0.75. How much it is? Into 0.03. Sorry, 0.003. It is, wait, it is 0.003 dear. 0.003, yes, because this value was bigger. It is 0.003. Now you will calculate. So it is nothing but 2.25 into 10 power minus 3. Now for the climbing CDI you got, they are asking here CD value. Okay, so CD is nothing but you can write CD is equal to CD naught. CD naught I told you it is constant. CDI for the climbing. So what is the CD naught? It will be constant. I told you it is constant value, so does not depend on the orientation of the aircraft. So CD naught will be constant. You can write 0.015. 0.015 plus 2.25 10 to the power minus 3. How much it is? Plus 0.015. It is 0.01725. This is the answer. Check. They have given 10 to the power minus 3. So you don't write 0.07125. You convert it into 10 to the power minus 3. So it will be 17.25. Yes or no? 17.25 into 10 power minus 3. So this is your answer. So what you have to fill? You have to fill 17.25. Guys, remember it. Okay. Fill in the blank. You have to be careful. 17.25 you have to write, because if you write 0.01725, if you write 0.01725, right, then computer will not take. It will take 17.25 because 10 to the power 3 itself it is given. I hope you understood, right? So this is the solution for this problem. I hope you all understand this. It was very simple problem. The thing is like it is a logical question. Okay, that logic you have to use. How it is cancel out? If you take the ratio of it, you have to take the ratio. Okay, so if you take the ratio, or directly I will write CDI steady level this and CDI for climbing flight this. Instead of W, you need to write W cos gamma, because here the formula in formula it is L. So for steady level L is equal to W, for climbing L is equal to W cos gamma. You need to write take the ratio, all the value like k cancel out, rho and s will be cancel out. In fact, velocity will also be cancel out because it is given constant. No, they have mentioned altitude and speed is constant. See, same altitude and speed, so velocity will be constant, altitude means density will be constant. So this is the solution for this problem. I hope you all understand. Still, if someone have any doubt in any steps, so immediately you write message on comment box, so I will reply. Okay, so keep hard working, and guys, like and subscribe the channel so that whenever I will upload any videos or any update related to gate, so automatically you will get notification. Okay, all the best, thank you.